Alright, let's do this, lesson 2. This is a really short lesson, and you're going to find it really easy too. What we're going to do is, it's called Properties of Isometries. I was calling it isometries until I watched the video. It's called Properties of Isometries. So what is a isometry? First of all, we got to talk about the definition of a transformation. In the lesson 1, we did reflections. This lesson we're going to do isometries, which has to do with transformations. Over here I have this diagram. Here are the 3 main transformations. You can take a shape and you can rotate it. You could reflect it. That's what we did yesterday. You flip it along a line, and all the points are equal distance from the line you flip it over. And this is a translation, which we'll talk about tomorrow, on Thursday, where you take it and you just move it, slide an object. Those are the main kind of transformations. So the transformation is a one-to-one correspondence between 2 sets of points. So this point goes with this point goes with this point, this point goes with this point. So, or actually this is a turn. So this goes with this goes with this goes with this. So that's what a transformation is. Now, a specific type of transformation is called an isometry. It's a transformation that preserves distance. And all of these ones over here are isometries. When you look at the video, you need to go to Mrs. Demai's math website and watch a video. Pretty interesting guy, just talking about isometries and transformations. I think that'll really help you if you watch it. So please go to the website and watch it. It's like 3 minutes long, not long. So after any of these transformations, turn, flip, or slide, the shape still has the same size, area, and angles and line length. So it's an isometry. There's a couple theorems which we're not going to prove. 2 of these I think you prove in your homework, this one and this one. They give you almost every step. You just have to fill in a few things and just use the answer book if you don't know what they're looking for. So transformation theorem 2 says, an isometry preserves collinearity and betweenness. So obviously if the shape's not going to change, that's what an isometry is. So if the shape's not going to change, then it's going to still preserve the collinearity of the shape and the betweenness of the shape. Theorem 3 says an isometry preserves angle measurement. The same thing. There's a proof in your book on this one, in your homework. If the shape's not going to change, which just happens, it preserves the distance. In isometry, the shape doesn't change, then the angle measurements aren't going to change. This is all kind of common sense. And this whole chapter is really easy, and there are hardly any proofs. I did all the problems in all the lessons, and there were very few proofs, and they had like 3 steps each, 5 steps or something. And the 4th one is a triangle and its image under an isometry are congruent. So this triangle is congruent to this triangle is congruent to this triangle, if it's an isometry. Now, if it's not an isometry, if it's a different type of transformation, which you're going to see in the video, then it's not going to be, the triangles won't be congruent. So that's about it for chapter 2. I'm just going to do a real quick example for you. This is problem in your homework. There's a whole bunch of these problems in your homework. See if I can find them. The problems say, trace the following figures, then sketch as accurately as you can the reflection of each figure through the given line. Draw the reflection images in a different color. So they're going to give you some sort of image and a line going through it somewhere, and you have to draw the reflection. So you have to draw reflection. Now you can kind of see what the reflection is going to look like. But if you don't see that, let me just show you how you can do this. This will help you later on. So what a reflection is, every point has a point on the other side that's where this line right here is the perpendicular bisector. So if we want to find the reflection of this point, we would go this distance and then we would go that distance more perpendicularly, and we put a point. Then we do the same with this one. We take this one, we would go perpendicular the same distance. Oops, this is hard on this thing. But you can see this from here to here and from here to here should be the same distance. I didn't get it quite right. So, and from here to here is the same distance as from here to here. Let's see if I can fix that one. This one from here to here, and then from here to here. So it's a little bit higher. And put a point. And then the same, we're gonna flip the whole thing. So this point needs to go on this side of the line. So it's gonna be straight down here. Can't see that point as well. See, this line right here is the perpendicular bisector of the reflection of this point. So we're going to do the same thing. This one down here perpendicularly. So from there to there, there to there. If you want to use a ruler to get a more accurate measurement, you can. And so then to draw the shape, we just have to connect the lines. They said use a different color, so I got the blue going on here. So we're going to connect this to this, and then we're going to connect this to this. It's easier to do on paper than using my little tool gadget thing here. I lost my line. Here it is. Here to here, and here to here, and come on, buddy. And here to here. It's not very nice, but you get the idea. You want to make sure when you're doing paper, maybe you should use some sort of measurement. Distance from here to here and here to here should be the same. It should be perpendicular. If you would draw a line to connect it, it would be perpendicular. This point has to reflect over the line to there. This point reflects same distance from here to here. This point from here, same distance on the other side of the line to here, and you connect them, and you get a reflection. So there's a lot of these to do, and it's really handy to know how to do reflections. So that's it for lesson 2. Please go to the math website and watch that video. We're going to be doing all different types of transformations in this chapter. Stick with it. Make sure you do your homework. Be ready for a homework quiz. Make sure you get every problem done in lessons 1 and 2. So that ends this lesson.